Hello everyone, welcome back to my channel. Today, we're going to dive into an exciting C# program that demonstrates how to perform asynchronous operations. Let's get started. First, let's look at the code we're going to walk through today. At the very top, we have some using directives. These lines are necessary for our program because they bring in essential namespaces. The system namespace provides basic types and base classes. Systemnet HTTP is required for making HTTP requests, and system threading tasks is essential for asynchronous programming. Now, let's dive into the main method, which is the entry point of our C# program. Here, we've marked the main method as async. This allows us to use the await keyword inside it. The async keyword tells the compiler that this method will be performing asynchronous operations. We start by printing a message to the console saying that we're beginning our asynchronous operations. Next, we call an asynchronous method called perform async operations using the await keyword. The await keyword is crucial because it tells our program to wait for this task to complete before moving on. This helps prevent our program from freezing while waiting for a long-running operation, like a network request. Now, let's jump into the perform async operations method. This method is where the magic happens. We are performing two key asynchronous operations here. First, we create an instance of HttpClient inside a using statement. This is important because HttpClient implements the disposable interface, which means it needs to be properly disposed of to free up system resources. Inside the try block, we define a URL for an API endpoint that returns some data. We then print a message to the console indicating that we're fetching data from this URL. Now, here's where we perform the actual asynchronous operation. The getStringAsync method sends a GET request to the specified URL and returns the response as a string. The await keyword pauses the execution of the method until the HTTP request completes. This is an example of non-blocking code. A program can continue executing other tasks while waiting for this request to complete. After successfully fetching the data, we print a confirmation message to the console and display the first 100 characters of the result to give a preview of the data received. In case something goes wrong during the HTTP request, we have a catch block that catches any exceptions and prints an error message to the console. This is a good practice to ensure our program can handle unexpected situations gracefully. Next, we simulate an asynchronous file write operation using another method. Here, we call write-to-file-async, another asynchronous method, and use await to ensure our program waits for the file writing to complete before continuing. Let's look at the write-to-file-async method. This method takes a file path and some content as parameters. It uses a stream writer to write the content to a file. The write-line-async method writes a line to the file asynchronously, meaning our program can perform other tasks while the file is being written. We use the using statement here as well to ensure that the stream writer is properly disposed of after writing to the file, freeing up any resources it was using. After the file write operation is completed, we print a message to the console to confirm this. Finally, after all these operations are complete, the program returns to the main method and prints a message to indicate that all asynchronous operations have been completed. And that's it. This is how you can perform asynchronous operations in C# using async and await. We've covered how to perform an asynchronous HTTP request and a file write operation while ensuring our program remains responsive. Thanks for watching. If you enjoyed this video, make sure to like and subscribe for more content like this. And as always, leave your questions or comments down below. I'd love to hear from you. See you in the next video.